Picture this. You're trapped inside a cave as hurricane-force winds howl outside at 120 miles per hour, driving snow horizontally through every crack and crevice. The temperature has plummeted to minus 58 degrees Fahrenheit. Outside, the storm has been raging for 23 days straight, burying the landscape under 40 feet of snow. Your modern emergency heating system failed on day 3. Your backup generator ran out of fuel on day 7. Even your emergency candles have been extinguished by the relentless wind infiltration. This is Northern Europe 19,000 years ago, during one of the most severe storms in Ice Age history. Modern meteorologists would classify this as an extinction-level weather event, the kind of storm that would overwhelm contemporary emergency services and leave millions without power for months. FEMA considers any heating system failure during such conditions a mass casualty scenario requiring immediate evacuation. Yet, somewhere in this frozen hell, a Paleolithic family huddles around a fire that has been burning continuously for over a month. No propane, no electricity, no industrial fuel supplies or modern insulation. Just a handful of Stone Age materials and human ingenuity. The fire hasn't flickered once, providing life-sustaining warmth while winds that would extinguish a blowtorch rage just feet away. By every law of physics and modern engineering, this should be impossible. The fire should have died within hours, leaving the family to freeze to death in conditions that would challenge our best survival technology. Instead, recent groundbreaking archaeological discoveries reveal firekeeping techniques so sophisticated that NASA's life support engineers are now studying them for space station applications. How did our ancestors achieve what seems to defy the fundamental laws of combustion itself? In 2020, the French National Institute for Preventive Archaeological Research made a discovery that revolutionized our understanding of Ice Age survival capabilities. Deep within the Dordogne Valley caves, researchers uncovered what they initially thought was just another Paleolithic hearth. But as they carefully excavated the site, they found something extraordinary: a sophisticated fire management system that had operated continuously for over 4,000 years, maintaining flames through the most severe weather conditions in human history. Dr. Marie-Claire Dubois, lead archaeologist on the project, described the moment of realization. We found charcoal deposits 30 feet deep, indicating continuous burning across millennia. But more shocking were the engineering systems: airflow channels, fuel storage chambers, and combustion controls that wouldn't look out of place in a modern furnace design. The statistics were staggering. Isotope analysis revealed these fires had burned without interruption through climate events that modern science considers unsurvivable. Core samples showed continuous ash, deposition during storms lasting up to 47 days, periods when surface temperatures dropped below minus 60 degrees Fahrenheit, and wind speeds exceeded those of Category 5 hurricanes. Thermal imaging analysis revealed the true sophistication of the discovery. These weren't simple campfires. They were precision-engineered heating systems that maintained stable temperatures within degrees across cave systems spanning hundreds of meters. The efficiency ratings exceeded those of many contemporary heating systems, achieving 94% fuel utilization compared to just 60% efficiency in modern wood-burning stoves. What left researchers speechless wasn't just the longevity, but the impossible consistency. Computer modeling revealed these fires had maintained optimal combustion through atmospheric conditions that would extinguish modern industrial furnaces. The technology was so advanced that aerospace engineers were consulted to understand how these systems could operate flawlessly in environments where contemporary heating technology fails catastrophically. The discovery challenged every assumption about Ice Age capabilities, revealing engineering sophistication that we're only now beginning to recreate with modern materials and scientific understanding. Between 25,000 and 15,000 years ago, Europe was locked in the last glacial maximum, the most hostile climate period in human history. Massive storms could rage for months without pause, bringing winds that would strip bark from trees and temperatures that would freeze human saliva before it could fall to the ground. These weren't occasional severe weather events. They were the normal conditions that defined daily survival for thousands of years. Cro-Magnon populations, scattered in small family groups of 8 or 15 individuals, faced survival challenges that would overwhelm modern civilization. A single fire failure meant death within hours for entire bloodlines. Fuel was scarce and precious. Every piece of wood burned had to be carefully rationed against uncertain weather patterns. Finding dry kindling during month-long storms was nearly impossible, and venturing outside to gather fuel often meant certain death. The physics of fire maintenance in these conditions were brutally unforgiving. Extreme cold increased fuel consumption exponentially. Fires that might burn for hours in moderate temperatures would die within minutes when temperatures dropped below -40 degrees. Hurricane-force winds created pressure differentials that would suck flames directly out of hearths. Humidity from melting snow would dampen fuel supplies, making ignition nearly impossible. The mathematics of survival were stark. Populations numbered perhaps 10,000 individuals across all of Ice Age Europe. Every family group was genetically critical to human survival. The loss of firekeeping knowledge in any community didn't just mean local tragedy, it threatened the continuity of human civilization itself. Yet, archaeological evidence shows these scattered groups not only maintained fires, but developed techniques so reliable they sustained population growth through humanity's darkest millennium. Modern emergency management considers any heating system failure during extreme weather a crisis requiring immediate outside intervention. These Ice Age families faced conditions that would kill modern humans equipped with contemporary survival gear, yet somehow created heating systems so dependable they operated for centuries without fail. The resources they lacked would astound modern survivors. No matches or lighters, no petroleum products, no metal tools for maintenance, no insulated shelters, and no backup heating systems. Everything depended on keeping a single flame alive through conditions that would challenge our most advanced technology. The first breakthrough came when researchers realized these Ice Age firekeepers weren't just burning wood. They had developed what we now recognize as the world's first integrated fuel management system. Instead of relying on random combustible materials, they had engineered precise fuel combinations that burned longer, hotter, and more reliably than anything modern campers typically use. The foundation was their understanding of combustion chemistry. Through generations of experimentation, they had identified specific wood species that burned at different rates and temperatures. They knew that birch bark contained natural oils that ignited easily even when damp. They discovered that certain fungi could burn for hours with minimal fuel consumption. Most importantly, they had learned to create what we now call composite fuels, carefully mixed combinations of materials that burned with controlled, predictable characteristics. But the real genius was in their fuel preparation techniques. Instead of burning green or partially dried wood, they had developed accelerated seasoning methods that could dry fuel in days rather than months. They created underground drying chambers that used residual earth heat to remove moisture from wood even during the wettest conditions. They learned to char materials in controlled burns that increased their combustibility while reducing smoke production. The fire construction itself was equally sophisticated. These weren't random piles of burning wood. They were engineered structures that maximized heat output while minimizing fuel consumption. They built fires in specific geometric patterns that created optimal airflow for complete combustion. They used stone reflectors positioned at calculated angles to direct and concentrate heat exactly where it was needed. Most impressive was their understanding of what we now call thermal mass management. They surrounded their fires with carefully selected stones that absorbed heat during burning and released it slowly when fuel was added. This created thermal buffers that maintained consistent temperatures even when fuel supplies fluctuated or storms disrupted normal feeding schedules. The efficiency was remarkable. Modern analysis shows their fuel consumption rates were 40% lower than contemporary wood-burning systems, while producing 60% more usable heat. They had achieved this through techniques that required sophisticated understanding of physics, chemistry, and engineering principles. But this was nothing compared to what researchers discovered about their advanced airflow management systems and the underground networks that kept these fires burning regardless of surface conditions. Here's where it gets sophisticated. These Ice Age firekeepers had created what archaeologists now recognize as the world's first climate-controlled heating systems. They hadn't just learned to maintain fires, they had engineered entire cave environments that provided perfect combustion conditions regardless of external weather, using techniques that required advanced understanding of fluid dynamics, thermodynamics, and atmospheric pressure management. The centerpiece was their airflow control systems. These weren't random cave formations. They were precisely modified environments with calculated air channels that provided perfect oxygen supply while protecting flames from extinguishing winds. Underground passages connected multiple chambers, creating pressure-balanced ventilation that maintained optimal combustion conditions even during the most violent storms. But the system extended far beyond simple air management. Archaeological evidence reveals sophisticated fuel storage networks, underground chambers that kept emergency supplies dry and ready for months at a time, connected by tunnels that allowed fuel transport without exposure to deadly surface conditions. These storage systems included different chambers for different fuel types, each with optimal humidity and temperature controls for preservation. The thermal management was particularly impressive. Dr. Dubois' team discovered evidence of what we now call distributed heating systems, networks of connected fires that shared heat and combustion air across entire cave complexes. If one fire began to fail, the system automatically compensated by adjusting airflow to other flames, maintaining overall temperature stability throughout the living spaces. Perhaps most remarkably, they had developed techniques for what modern engineers call combustion optimization. They understood that different atmospheric conditions required different burning techniques, and they had created systems that automatically adjusted to changing weather patterns. During high-pressure systems, vents would be open to increase oxygen flow. During storms, protective barriers would engage to shield flames from wind disruption. The mathematical precision was astounding. Airflow calculations followed engineering principles that wouldn't be formally recognized until the development of modern HVAC systems. The positioning of vents, reflectors, and fuel storage followed geometric patterns that maximized efficiency while minimizing construction effort. Every element was integrated into a unified system that operated with mechanical reliability. Modern computer modeling reveals these systems were so sophisticated that they actually modified local microclimates, creating stable thermal environments that could maintain comfortable living conditions during external weather that would freeze modern homes solid within hours. These Stone Age engineers weren't just keeping fires alive. They were creating controlled environments with climate management capabilities that rival contemporary heating systems. The most breathtaking revelation came when researchers realized these fire-keeping systems weren't just family innovations. They were part of a continent-spanning knowledge network that connected Ice Age communities across thousands of miles. Identical heating designs, fuel preparation techniques, and even construction symbols have been found from Spain to Russia, revealing a sophisticated information sharing system that preserved and transmitted fire-keeping knowledge across generations. The training required to operate these systems was extraordinary. Evidence suggests specialized firekeepers underwent decades of education, learning not just combustion techniques, but also weather prediction, fuel chemistry, airflow engineering, and emergency protocols. These weren't casual family tasks. Fire maintenance was handled by highly trained specialists whose expertise was considered so valuable that entire communities would support them for life. The knowledge preservation methods were equally sophisticated. Researchers have discovered cave paintings that aren't just art. They're detailed technical diagrams showing fire construction, fuel ratios, and maintenance procedures. These visual instruction manuals were positioned strategically near hearth systems, providing reference guides for complex operations that required precise timing and perfect execution. But perhaps most impressive was the community coordination required during extreme weather events. Archaeological evidence shows that when major storms approached, entire populations would mobilize with precision that would impress modern emergency responders. Specific individuals had assigned roles. Some maintained primary fires, others managed fuel supplies, still others monitored backup systems and coordinated repairs when storms damaged ventilation networks. The system even included what we'd now call redundant safety systems. Multiple independent fires were maintained in different cave chambers, connected by the airflow network but capable of independent operation. If one system failed, others would automatically compensate, ensuring that life-sustaining heat was never completely lost, regardless of equipment failures or extreme conditions. The social organization required to maintain this system reveals Ice Age communities far more sophisticated than we ever imagined. These weren't desperate survivors huddled around random campfires. They were highly organized societies with specialized knowledge, advanced technology, and social structures capable of maintaining complex systems across multiple generations. The fire-keeping network wasn't just about warmth, it was the foundation of stable communities that could thrive in Earth's most hostile climate. Today, as climate change creates increasingly severe weather events and power grid failures become more common, researchers are desperately trying to understand and recreate these ancient heating techniques. The 2021 Texas winter storm left millions without heat for weeks, while these Ice Age systems operated flawlessly through far worse conditions for thousands of years. Modern heating systems fail regularly during extreme weather due to power outages, fuel supply disruptions, and equipment malfunctions. The Federal Emergency Management Agency reports that heating system failures are now the leading cause of weather-related fatalities. Meanwhile, these Paleolithic heating networks continued operating through the most severe climate conditions in human history, providing reliable warmth regardless of external circumstances. Energy researchers are particularly interested in the efficiency techniques. As fossil fuel costs soar and environmental concerns mount, the idea of heating systems that achieve maximum output with minimal fuel consumption is attracting serious attention. Several Scandinavian countries are piloting programs based on Ice Age designs, reporting remarkable improvements in both efficiency and reliability. The airflow management systems are proving especially relevant for sustainable architecture. Modern green building designers are incorporating principles discovered in these ancient caves, creating naturally ventilated structures that maintain comfortable temperatures without mechanical heating systems. Early results show energy consumption reductions of up to 70% compared to conventional buildings. Perhaps most importantly, the community-based maintenance model offers solutions to the infrastructure vulnerabilities that plague modern society. Studies show that decentralized heating systems, based on local knowledge and community cooperation, are far more resilient than centralized utilities that fail catastrophically during extreme weather events. Current research projects in Alaska, northern Canada, and Siberia are attempting to recreate these ancient heating systems using traditional materials and techniques. Early results are promising, but researchers admit they're still far from understanding the full sophistication of the original designs. The knowledge we've lost represents critical survival capabilities that could save lives during the increasingly severe weather events that climate change is bringing to modern communities. Think about this for a moment. Your own ancestors survived by maintaining fires through conditions that would overwhelm our most advanced heating technology. Every person alive today carries the genetic legacy of firekeepers who possessed knowledge so sophisticated that modern engineers are still trying to understand their achievements. What survival wisdom have we lost in our dependence on centralized heating systems and fossil fuels? How might your own ability to maintain warmth during emergencies compare to these Ice Age masters who could keep flames alive through month-long storms? These ancient firekeepers didn't just survive impossible conditions. They created reliable heating systems that operated for thousands of years without outside support. The next time your power goes out during a winter storm or your heating system fails, remember that your ancestors had developed heating techniques so reliable they sustained human civilization through its greatest climate challenge. Their success wasn't primitive luck. It was sophisticated mastery of principles we're only beginning to rediscover. Here's what I want you to consider. What other ancient technologies have we dismissed as outdated that might actually be more reliable than our current systems? How might learning these traditional skills enhance your own emergency preparedness and self-sufficiency? Share your thoughts below. Have you ever had to maintain heat without modern systems? What traditional firekeeping knowledge has your family preserved? Your experiences could help researchers understand how to bridge ancient wisdom with contemporary emergency preparedness. The story of Ice Age firekeepers isn't just history. It's a blueprint for creating more resilient, community-based approaches to one of our most fundamental survival needs. Our ancestors didn't just survive humanity's darkest millennium. They mastered it with techniques that could revolutionize how we approach heating and emergency preparedness today. Perhaps it's time we learn to tend the eternal flame once again.